This video is about visual representations of division. So hopefully you're pretty confident by now. You know that I like visuals. I like to see things. I think it can be helpful for some of you to have these visual representations of division. So visual representations. First off, division using objects. So we've done addition and subtraction and multiplication using objects. So division using objects. For example, 35 divided by 5. So here are my 35 objects. Ooh, lightning bolts. So again, division asks how many 5s are inside 35. And I really want you to beat this into your head, right? The definition of division is how many 5s are inside of 35. So there are two ways to do that. So here I did groups of 5. So here we're 5, 5, 5, 5, 5, 5, 5. So I can see right there that there are 1, 2, 3, 4, 5, 6, 7 groups of 5. 7 groups of 5 tells me that 35 divided by 5 is 7. Or I can think of this as 5 groups. So now I made 1, 2, 3, 4, 5 groups, and I made them equal, and that is really important. So I made 5 equal groups. So my answer is then how many objects are in each one of those groups. So I have 1, 2, 3, 4, 5, 6, 7 lightning bolts inside of each group. So 5 groups, 7 objects in each tells me that 35 divided by 5 is 7. Now, division using a number line. 36 divided by 12. This is asking how many 12s are inside of 36. So in a number line model, that's just asking how many arrows of length 12 fit inside the space between 0 and 36. So I draw out a number line, so make sure it goes from 0 to 36, and then I'm just going to put my 12 arrows. So I have one red arrow that reaches to 12, my second red arrow reaches from 12 to 24, my third red arrow reaches from 24 to 36. So that tells me that 3 arrows fit exactly between 0 and 36, so 36 divided by 12 equals 3. Now, if they don't fit exactly, it means that you have some left over. So it would fit 3 and a little bit more times, or 2 and a little bit more times. Okay, division using area. And this is using think multiplication. So using what we know about multiplication to then use our area model. So remember, with multiplication, the length of the side times the length of the other side multiplied together gives you the area of that rectangle. So one way to think this through is we now know the area and we know one side. So let's use that one side and let's build our new area. So let's do this as an example, 24 divided by 6. So I'm going to start with 6 because I know that the length of one side of my rectangle needs to be 6. So there it is. What I don't know is I don't know how long this side of the rectangle is. Okay, that's still the unknown. So I'm going to start with my 6 and then I'm going to build until I have an area of 24. So right now I only have an area of 6. So I'm not done. So let's put another row. So now I have another 6. So again, notice this side of my rectangle still has a length of 6. And now my area is 12 if I count all those up. So I don't yet have an area of 24, so I'm going to keep going. So again, I still have a side of 6. Now I have an area of, we count those up, 18. Not quite what I want, so let's keep going. Put on another row. So now I have one side that is 6. I now have an area that's 24. So now I need to figure out what the other side is. Well, I just count it. 1, 2, 3, 4. So this is showing me that 6 times 4 is 24. It is also showing me that 24 divided by 6 is 4. Another interpretation of area is to think of it in terms of the grouping. So instead of starting off with one side and sort of building the area, what we're going to do is we're just going to start off with an area of 24. So we're going to start off with the original area, and then we're going to break off areas of 6. So remember, division can be thought of as how many 6s are inside of 24. So I started with a rectangle that has 24 pieces in it. And now I'm going to break off 6, or in this case, I'm going to shade them. So this orange patch, that's 6 parts, has an area of 6. Then this turquoise, there's another 6. So far, I know that there are 2 6s inside of 24. And then I'm going to shade these purple ones, so there's another 6. I'm going to shade these red, there's another 6. And this fits perfectly, which tells me that there are exactly 4 6s inside of 24. So 4 6s inside of 24 tells me that 24 divided by 6 is 4. Now another way to think of area is to again start with the 24, but now instead of taking areas of 6, we're going to break it into 6 different groups. So I chose 6 different colors. So one group is going to be green. So I'm going to give that piece to the green group, that piece to the purple group, that piece to the blue group, that piece to the maroon group, that piece to the yellow group, and that piece to the gray group. So far, each of my 6 groups has 1 piece. Again, each of my 6 groups has 1 piece in it. And then I'm just going to continue from there. I'm going to give the next piece to green, and then one to purple, then one to blue, etc. So my next set looks like this. So far, each of my 6 groups has 2 pieces. I keep going. Each of those different colored groups has 3 pieces. I keep going. Each of those have 4 pieces. So I have 6 groups. They all have exactly the same number of pieces, in this case 4, and that totally takes care of my 24. Okay, the entire area was passed out. So each of the 6 groups has 4 rectangles, so that tells me that 24 divided by 6 is 4. So in summary, division can be represented by objects, number lines, areas, and 2 different ways to think about areas, similar to the 2 different ways to think about grouping. And remember, division is asking how many times can one number fit into another number.